This video will cover the topic, Multiplicative Property of Equality with Signed Fractions.
What is the multiplicative property of equality, and what do we use it for?
In certain instances, a variable that you are attempting to solve for is being multiplied by a fraction, and sometimes that fraction is negative. The multiplicative property of equality states that if you multiply both sides of an equation with an equality, that equality will hold.
I don't know. That doesn't really sound like it will work.
It's actually a property that's fairly easy to confirm. Let's take a look. 6 is equal to 6, since they're the same number. But what if you were to multiply both sides by -2?
Well, we would simplify both sides and end up with -12 equals -12. So I guess it does work.
Now, in terms of variables and fractions, it is important to remember how to negate a fraction. If you want to solve for the variable x, but have an expression of the form -a over b times x is equal to c, where a, b, and c are constants, we need to use the multiplicative property of equality. To help solve this expression for x, it can be useful to rewrite this equation as -1 times a over b times x is equal to c. Now, in order to get the x by itself, see that we need to get rid of both the -1 and the a over b and move them over to the other side of the equal sign. To get rid of the -1, we multiply both sides of the equality by -1, which results in -1 times -1 times a over b times x is equal to c times -1. This simplifies down to a over b times x is equal to -c. Now, in order to completely isolate the x, we need to move the a over b over to the other side of the equal sign. It is important to note that the multiplicative inverse of a fraction is computed by switching the numerator and the denominator. So, the inverse of a over b is b over a. We are going to use this property to isolate the x by multiplying both sides of the equality by b over a, which gives us b over a times a over b times x is equal to -c times b over a. This expression simplifies down to x is equal to -c times b over a, which is our final answer because we have successfully solved for the variable x.
There were a lot of letters in that. I don't quite understand. Could we do a real example?
Of course! Let's go ahead and try this example. In this example, we're being asked to solve for w in the equation 21 is equal to -3 over 8 times w. What do you think our first step should be?
We would take out the negative first, right?
That's right. It can be helpful to visualize this by rewriting the expression as -1 times 3 over 8 times w is equal to 21.
Okay, so I know that we now have to get rid of the negative and the fraction, but how do we do that?
Let's start with the -1. In order to get this away from the w, we have to multiply both sides by -1. So now our expression reads -1 times -1 times 3 over 8 times w is equal to 21 times -1. This simplifies down to 3 over 8 times w is equal to -21. Now that we've gotten rid of the negative, let's get the fraction away from our variable w by moving the fraction over to the other side.
Oh, I see it now. This is where we'd use the multiplicative inverse, right?
That's right. The multiplicative inverse of a fraction switches the numerator and the denominator. So, in this instance, we have to switch the 3 and the 8. So, the inverse of 3 over 8 is 8 over 3. Now, let's go ahead and multiply both sides by 8 over 3 to get rid of the 3 over 8. Our equation now reads 8 over 3 times 3 over 8 times w is equal to -21 times 8 over 3. When simplified, we find that w is equal to -56. And with that, we have successfully solved for w.
Okay, I think I understand it now. So, in order to solve an equation using the multiplicative property of signed fractions, we take the inverse of the fraction that's on the variable, multiply both sides by the inverse we found, and then solve for the variable we were looking for?
That's right. It sounds like you really understand the topic.